Welcome to my video. It's the number 5 in my energy series of solving work problems. In this video I want to do a couple of examples of work problems, but before we do that, let's do a quick review. Work is the transfer of energy caused by a force acting through displacement. So this is our weight, and there may be some kind of box or something. It's on the floor. This force pushes on it. Maybe it's a person pushing it or a forklift, and it goes through a certain distance. So it takes amount of work. The work is defined, if we write it in the forms of vectors, is equal to the force dot product with this change in displacement, this D, change in R, change in position. Now, from the definition of the dot product, we know that the work is equal to force times the magnitude of the distance of the displacement times the cosine of the angle between these two vectors. So that's the formula we're going to use most of the time. So our force has a unit of newtons, and our displacement has units of meters, and that's going to be how far the object moves. And theta is the angle between the force and displacement. In this case, they were all lined up, everything went right along the floor, so theta would have been 0 in this case. But if we have the force coming in from a different angle, then this theta, that would be the difference between the two vector directions. And we know W is a scalar. It's just a number because it's a dot product of two vectors. And the units of that is going to be joules, the same as energy. Now let's do example 1. And that's going to be with a lawnmower. So let's draw our diagram here. So we've got our mower, well, that's the ground. And there's the mower. And I know it's not a very good looking mower, but it'll have to do for them. It kind of looks like a car almost. Here's the handle coming up, okay? Now, our person is up here and is pushing down on the mower. And so this force pushing down by the person is 75 newtons. Okay, so here's the man pushing down on the mower. Now the mower is going to go this direction, so we're interested in the vector that goes this direction. That's our force, our net force moving it that way. And we know that this angle is 35 degrees here between the mower handle and the horizon, or the horizontal. And the mower is going to go 15 meters. So that's how far we're going to push the mower, for 15 meters. So what is the work? How much work is required to move this lawnmower with a force of 75 newtons pushing down that direction, 35 degrees relative to the direction of motion. So we're going to use our equation. So work is equal to the force times the displacement times the cosine of the angle between them. So in this case, we know our force is 75 newtons, our distance is 15 meters, and we want the cosine of the angle of 35 degrees. All right, so let's get our calculator out and do that. Let's clear 75 times 15 is going to be equal to 1125. Now let's take the cosine of this angle. We want to make sure we're in the degrees mode. To do that, let's clear it. And let's do the cosine of 35, enter. That's 0.891. We'll multiply that by 1125, enter. And we're going to get 921 joules. So that's the amount of work expended by moving this mower 15 meters with a force pushing down from the person mowing That's a direction of travel. So that's really the net force we're interested in, force in that direction. And so this equation gives that, where that's the angle between it. So there's our first example of a lawnmower. Now let's do another example. In this one, we're going to look at negative work. The first example was an example of positive work. It's work done on the object. Now we're going to have a frictional force. So what we have is a crate sliding on a floor. So somebody gave a box a shove. So here's the floor. Here's this box. And the box is just moving at a velocity. Somebody pushed it. And it's going to slide for 12 meters. Now, opposing the direction of travel, which is going this way, we're going to have a frictional force pushing in the opposite direction. And that frictional force is going to be 55 newtons. So here's our situation. Somebody shoved a box, is sliding this way, but friction due to the surface and the box interaction is 55 newtons pushing back that way. So now we're going to have a little different situation. So we got the work is equal to force times the displacement times the cosine of the angle theta. Okay, our force here's 55 newtons. And we know our displacement is 12 meters. The box slides 12 meters before it comes to rest. And then our cosine now, what's our angle of theta? In this case, it's going that way. The direction of travel is to the right. The frictional force always opposes the direction of travel. So that's going to be 180 degrees. So in this case, we'll get our calculator out, plug in those numbers, turn it on, clear it. So 55 times 12, that's going to be 660. 660. Now we want the cosine of 180. Let me get this out of the way here. We write that, so 660 times the cosine of 180 degrees. Now, let's do the cosine of 180 degrees. Clear that. Cosine, and we are in the degree mode. We check that right there. It's to a radian, so 180, enter, and that's -1. So we've got 660 times -1 is equal to minus 660 joules. So you can see this is a negative force. And that's a resistive force pushing against the movement of the box on the floor. So that's how much work was required to stop the box. So this was an example of negative work, and our other one was an example of positive work. Well, I hope you got a little bit more out of these two examples on work, and it kind of helps solidify the idea in your mind. And I want to thank you for watching, and don't forget to leave a comment.